Cbse class 11 projectile motion in plane. Consider an object which is projected from the ground at a velocity of v at an angle of theta to the ground. This object will take a parabolic path, it will reach the maximum height and it will come to the ground, it will reach the ground. At this point, the distance, vertical distance will be 0. It will have two components of velocity at any point of time t. One is the vertical component of velocity Vy, the other one is the horizontal component of velocity Vx. The object will have vertical acceleration which is due to the acceleration due to gravity, and horizontal component of acceleration will be 0. Therefore, the horizontal component of acceleration Ax equal to 0 and vertical component of acceleration of the object Ay is equal to g, which is acceleration due to gravity. T is the time, g is acceleration due to gravity, x is the horizontal distance travelled by the object at any point of time t. The distance covered by the object horizontally at any point of time t. Y is the vertical distance covered by the object at any point of time t. Now let us derive this equation. Now x is equal to velocity into time, distance, horizontal distance covered by the object, v cos theta into t, horizontal component of velocity into time. So the time is equal to x by v cos theta. Call this as equation 1. We know that y is equal to v sin theta into t minus of gt square. This is according to the equation of motion. So substitute 1 in 2. It becomes y is equal to v sin theta into x divided by v cos theta minus of into g into x square, because t is equal to x by v cos theta. Therefore x square by v cos theta whole square. Therefore it becomes y is equal to x tan theta. Here v cancels, sin theta by cos theta, tan theta, therefore x tan theta. X tan theta minus of into g x square by 2v square cos square theta. Therefore this becomes 1 by cos square theta, here secant square theta. Therefore y is equal to x tan theta minus g x square by 2v square secant square theta. So this is the equation for the projectile. So this is a parabolic equation. It is a parabola. Right? It's an equation of parabola. Therefore, it is parabolic path. Therefore, the projectile will follow parabolic path. R is the range, we will find it.